The Earth's inner core is a solid and extremely hot sphere composed of nickel and iron. It lies approximately 5,100 kilometers beneath our feet and is slightly larger than 2/3 of the Moon's size. Over the past 2 decades, the movement of the Earth's core has been a hot topic in scientific research. Some theories suggest it rotates faster than the Earth's surface, while others propose the opposite. Now, new findings have emerged. A research team from the University of Southern California, USC, has concluded that the Earth's core is losing speed. The study utilized data from 121 repeated earthquakes around the South Sandwich Islands in the South Atlantic, recorded between 1991 and 2023. Additionally, data from Soviet nuclear tests conducted between 1971 and 1974, along with numerous American and French nuclear tests, were used to analyze the Earth's inner core. By examining how seismic waves accelerate, refract, and reflect, the researchers calculated the position and movement of the inner core. They discovered that the inner core's rotation began to slow around 2010. Researchers believe this slowdown might be linked to dynamic interactions between the liquid outer core and the Earth's mantle above it, influenced by gravitational forces. The first time I observed seismic data indicating this change, I was stunned, said John Vidal, a researcher at USC and one of the study's authors, in a press release. The inner core's rotation has been slowing for several decades. While previous studies have suggested similar shifts, this new research provides the most compelling evidence yet. The potential implications of this phenomenon for life on Earth are still unknown, such as how it might affect day-to-day conditions. Scientists hypothesize that the slower rotation of the inner core may cause slight variations in the Earth's day length, by mere fractions of a second. The research team aims to map the trajectory of the inner core more precisely in the near future, hoping to uncover the reasons behind these changes. The Dragonfly expedition aims to search for signs of life on Titan's surface, where ethane and methane form lakes, much like water does on Earth. In the early universe, only hydrogen and helium existed. Heavier elements formed later through fusion processes in stars. Most astronomers believe the first stars ignited when the universe was between 50 and 100 million years old. If this timeline holds, it would have been too late for the conditions Loeb calculated for early life to develop. Loeb's theory hinges on the assumption that stars formed earlier than this. If stars had ignited, for example, just 12 million years after the Big Bang, the necessary building blocks for life could have emerged in time. However, Loeb himself acknowledges that such early star formation is unlikely. According to current cosmological models, this seems highly improbable, Loeb said in an interview with Illustrerad Vetenskap. Despite this challenge, Loeb suggests that background radiation might have maintained liquid conditions between 30 and 90 million years after the Big Bang. If the first stars formed 50 million years post-Big Bang and exploded into supernovae 5 million years later, these events could have provided the heat necessary for life to begin evolving. During its descent to Titan, Dragonfly will examine other possible liquids that might support life, such as ammonia, propane, methanol, ethane, and methane. Methane, for instance, can remain liquid between -182 degrees Celsius and -161 degrees Celsius, offering entirely different possibilities for life compared to Earth. Methane-based life forms would likely differ from those on Earth, where water is the primary solvent. However, if signs of life are discovered on Titan, they could suggest a shared origin, pointing to life's building blocks traveling through interstellar space on comets or asteroids. NASA's Dragonfly spacecraft is scheduled to launch in 2027 and reach Saturn's moon Titan by 2034. It will land near one of Titan's lakes and analyze the surface to determine whether life, based on methane or another solvent, exists or has ever existed there. If signs of life are discovered, it could confirm that life is not unique to Earth and may even point to a common origin for life throughout the cosmos.